Alright, this will probably be the hardest one we have to work with. First and foremost, always, I didn't say this in the previous videos, we always want to look for GCF first. Now obviously in the other three examples we did, there was no GCF. So we didn't have to pull anything out. We saw they were all perfect squares, and we were able to work our method to be able to factor those out. Here is a little different story. We have a possible GCF, 50 and 32. What goes into both 50 and 32? Well, I'm going to let you know that 2 goes into both of those because they're even numbers. So I'm going to pull out a factor of 2. And how many times is 2 times what gives us 50? 25. And then x squared stays the same. 2 times what gives us 32? 16. Now, do we have anything that goes in 25 and 16? Absolutely not. But what do we notice about 25 and 16? They're both perfect squares. We have got to recognize that 25 and 16, and even x squared, that's how we know all three of those are perfect squares. So we're going to factor just this side and keep the 2 on the outside to factor it out completely. So we're going to bring the 2 down, and then we're going to write our parentheses here. Well, what is our a here? Our a, 25, how do we get that? Well, 5 times 5, so 5. How do we get x squared? With x. And b, 16, where did that come from? Came with 4. We're going to put our plus, put our minus, same steps. Our a was 5x, our b is 4, our a, 5x, our b is 4. And that would be our answer. Again, all we did first that was kind of different was we factored out a GCF, and then we did our difference of squares. It's the only thing we did different there. Other than that, it's the same process, finding our a, finding our b, plugging it in, knowing it's plus or minus. And it doesn't matter if you want to put the minus on this side and the plus on this side, it doesn't really matter. I like to deal with plus and then minus. So however you want to do it, that is our last example for difference of squares factoring.